Okay, hey. So here's what we're gonna do. We're gonna go over our test scores. I'm gonna put it up on the board so you can see my answer key. We're gonna go through all the tests. You have a 1 week from today if you wish to retake. Anyone can retake. You always get better of the two scores. No risk gamble, so you can always retake if you like. If you failed it, you have to retake it. I don't know if anyone did, but if you did, you have to retake. It's not an option, you have to. Now when you retake, you just have to come in with me before or after school, like review, like the problems you missed. And then we'll set up a time within the week from today, right, that you can retake it. Preferably when you stop in before or after school, because you have to stop in. If you can't make it, you don't get to retake it. You have to make the time to earn it. Now, if you're going to come in, don't come in Friday after school, because we're setting up homecoming dance. I will not be available. Apologies. If you're going to retake, you have to review with me this week, and the latest you can retake is Monday. Usually what happens, a lot of people come in today and tomorrow, and they kind of take it Wednesday or Thursday. That way it's out of the way. But I just want to make sure everyone gets a chance where you're actually taking the time to review, okay? Nolan, if you haven't already, I need your practice guide. You've never turned in your practice test. So, all right. Okay, I'm going to hand these out now. I do want the test back. Well, thanks. I do want the test back. Don't crumble it up. Don't throw it away. I'm collecting these back. That way we have something to go over when you come in. Okay? But you can see it. We're going to go through the answers here in a minute.
Oh, well, I'm afraid to check it out. God. When did you get
I got 80%. 69? 69.
It was all of this.
Isn't it even supposed to be still pretty good?
If you look.
Okay.
I'm not dumb.
Okay, all right. So, take a look at them. Let's go through every question, every answer so you can see what you missed. Now, here's what I asked. Get rid of any writing utensil in front of you. I don't want to have that excuse that, hey Ward, I did it right, and I watched you literally like filling in answers. Just get rid of the pencil right now. I've checked them, I've double checked them to make sure I made the correct markings on there, so there shouldn't be any reason like, Ward, you marked it wrong and I had it right, so keep that in mind. Okay? So don't do that to me. Alright, but again, you can retake if there's any questions. Now, if I made a mistake, an honest mistake, because it does happen, I'm human. So if I made an honest mistake, I will give you credit back for it. If you got a freebie, like you got it wrong, like you're about to see the answer and you got it wrong, but I didn't mark it, that's a freebie, that's my mistake, you get to earn that, that's yours for free. That's how I always work. I don't take points away after I figure out I made a mistake. So, does that make sense? So, no risk gamble, it's my own mistake on those. So, alright, here we go. A line that has two endpoints, automatically a segment. It has two endpoints, I don't even have to think about it, it's a segment. Geometric figures that cross, they intersect, they cross, duh. Moving on, angles that share a common vertex. Type of angles. There's only a couple words over there that have angles in them. Adjacent angles is one of them. They share a vertex in the side. Space, the set of all points. I think that was the same word on our practice guide in the exact same spot. I didn't even move it. Moving on, a vertex is the common endpoint of two rays. It's like where they meet. It's called a vertex. Points that are contained on the same flat surface are coplanar. That definition was on our practice guide, we just didn't have the word. I think I even said it when we were doing the practice test. Points that are on the outside of a figure. Well, it literally has the word points in it. Go find the one that has points in it. It's probably exterior. So, next one. A measure of an angle is exactly 90. That is a right angle. It's one angle, an angle. It's not complementary. And a lot of people put in complementary there. Complementary is when you add two angles. Right angle is just one angle. Right? A line segment or plane that intersects something in half is called a bisector. Complementary, adding two angles to make 90. Collinear, points that are on the same line, they're co-lining with each other. Congruent is equal in size, shape, and measure. A line is a figure that continues in both directions, doesn't stop. And then a midpoint is a specific point, literally has the word specific point, midpoint, right? a specific point in geometric figure that lies at the center, the middle. Okay, questions on the vocab. Now, if you retake, I'll get to your question here in a minute. If you retake it, I pick new words from the chapter, new definitions. I go from section 1.1 to 1.5. I just pick 12, 13 words, and you get 12 or 13 blanks. So if you are retaking it, they will have slightly different words there. Question?
So what was the one with the set of all points?
Space. Space. That was the same one on our practice guide. Average? I think in this class, I think average was out of 66, it ended up being 55 or 56, something like that. There were some good scores, and then there were some really low. So, overall, I think the average was, the average in all three geometries pulled to like 59 or 60. But, all right. Okay, number two. Okay, all right, number two. There are some crazy answers people were putting on these. There's a lot of different ones. I'm just showing you an example, okay? So don't feel like these are the only answers you could have put. There's a couple others. Okay, so name lines that are in this plane, that are contained on it. Okay, so only in plane B. Here it is. Line N and line M. Now, if you said the two-letter system like YR and WY, fine. But you can't say line L, because I even told you on test day, this is poking through the paper. It's not on it, it's poking through it, right? It's dashed. So, but here's the weird thing. So some people said, name lines that are only in plane B. Line M, line L. So they got that wrong, right? Because they put L, L's not on there. Or ZR, whatever they want to call it. But then the next line down, they said, name a line that is not on plane B. They said the same line, they said line L again. It can't be on and off of it. You can't have it in both spots, you gotta pick. So there's a goofy answer. Next one, name lines that contain point R. You better have R in the name. Now if you want to call it M and L, fine, those are the lines, but YR, ZR, fine, just put arrows above them. You don't need to put the word line in front of it. Like that, you only have to put line if you use cursive letters. Some people are like mixing letters, and you can't use like 3 letters, the 2-letter system when you name lines. I think the goofiest answer was this next one, number 4. Name the intersection where M and N cross. Well, they cross at Y, right? I had somebody tell me an angle. That's no. An intersection's a point. Point Y. That's where M and N cross. Name another name for line N, WY. And you gotta put arrows. Okay? Alright, moving on. Let's get to the next page. Okay. Okay, we had to measure the goldfish. Find the length. Okay, here it is. It's 5.7 or 5.7 or 5.8, 5.8, that type of thing. I have both answers if I zoom out. Now, the reason I'm bringing this in, I had somebody tell me it's 5.3. I have really bad vision. I can see there's a difference there, so it's not 5.3, just saying. Let's move on. Okay, number 4, you had to draw. Y is in between X and Z, so Y is right here. I filled in 7A, the 5B, I add those two together, make the whole stick. You can see my math here. Subtract A across, you get A over here, divided by 6, you get 4. And then you have to plug it back in. So if I plug because I have to find YZ, if I plug the 4 in here, 5 times 4 is 20. That's the one I'm looking for. Read the instructions, it tells you which one you have to plug it back into. Most common mistake, people didn't plug it back in. Or they didn't even solve. They didn't even draw it. So, next one. XY is 11D, this one's a 9D minus 2. The whole stick is 5D plus 28. Add the 2 small pieces equal the big piece. Subtract the D's across, add the 2 across, so I get 15D equals 30. Divided by 15, you get 2. Plug the 2's back in, and you can figure out what each stick is. That's what I wanted. Alright, moving on. Those were worth 5 points each. Some people didn't even attempt them. Seriously, we did them in practice test day. If you didn't know how to do them, come and ask a question. It's ridiculous. Number 5. I tried to pick the easiest ones possible. J to M. -7 up to 0. Literally is 7 steps. It's not even, you don't even have to think about it. -7 up to 0. 7 steps. M to P. 0 to 5. It's literally 5 steps. Like 0 to 5. Right? So, what? Yeah, so like I tried to give like easy ones so you didn't have to even think. At least I got those. Alright, let's move on. Number 6. Some people did not read number 6 right. Yeah, I do make fun of people when we do this. Just get over it. This is what I do. It gives me my jollies. Alright, so number 6. we have to find the distance, right? Some people were finding like midpoint and other weird stuff. It literally says find the distance. Like the distance room was on the board over there. It was on the like PowerPoint we were doing. Like it was everywhere on test day. So you have to, for the distance, you have to subtract the x's, that's a -4 and 3. And then you have to subtract the y numbers, which are 2 and -1, that makes 3, because the two negatives cancel. But when you square the -7, you should get a positive number. Anytime you square something, you're taking it times itself, the negative cancels out. I warned you that on practice test days. You should not have negative numbers. They should cancel out, and then you can add together to make 58. A lot of people were like kept the negative, so they're getting like 40, and they're taking the square root of 40, it's supposed to be 58. The square root of 58 is 7.6, and yes, you had to type it in the calculator. If you missed a point and you're like, where about 58? You didn't tell me the decimal, I told you you had to use a calculator. There are 10 in the back, you should use one. Okay? Alright, moving on. Alright, third and final page, and yes, I'll stop making fun of people here in a minute. Alright, S to T. You can literally see me draw my dot. That was the first second I looked at the picture. Like, boom, there's the middle. Right? You can see I put my dot on the paper. Like, there's the middle. And then I have to like show where it's at. So you have to add the two x numbers, -3 and 4, and then divide by 2. Add the two y numbers, 2 and 5. Add those two together, divide by 2. And this turns out to be 1/2 and 7/2. And if I divide, I get 0.5 and 3.5. That is literally where my dot's sitting. Over half, up 3.5. It's literally where the dot's sitting. So that should make sense. Now on the other one, for EF, you have to add the x's together and divide by 2, so -7 and 3, divide by 2. Add the y numbers, 5 and -5, that makes 0, divide by 2. Divide these both by 2, I get -2 and 0. That's it, it's a coordinate. Some people were like giving me numbers. I don't know how you're getting your numbers from, but it's just like a coordinate. Like, I just want to know where the dot sits. This is literally where the halfway point is. You can actually see my pencil was there. I have a dot sitting there. That's -2 over up and down 0. So, alright, moving on. Some people get some weird numbers, I don't know. Number 8. Alright, here's where the nightmare started. Try to grade number 8. You can even say it. You can even see it like in my test. There's many different angles and many different examples you can have. There's so many, in fact, I couldn't count them all, and I didn't want to put every example on my paper. I'm just going to show you a few. The reason why there's many is because I told you, when you look at these pictures, you can add your own letters, you can add your own numbers, you can do other things so that it makes more sense to you. Some people took advantage of that, and they got nice answers. Some people didn't, and then they didn't know what they were doing. So, yeah, I'm going to make fun of some people, because there's some crazy answers that were here. Okay, name the vertex of angle 4. Does everyone see that 4 is right here? What's the dot right next to it? Point Q. That's what I want. That's the vertex. It's a dot. It's not an angle. Okay. Name the sides of angle 3. Okay. Here is the craziest answer I got. And yeah, I'm going to make fun of somebody. I don't know if they're in here, but it might be in the other class. Name the sides of angle 3. Angle 3 is right here, right? Does everyone see angle 3? Here's what I got. Name the sides of angle 3. What? You failed on so many accounts, I can't even comprehend where your mind was at. You just gave me 3 numbers. Those are individual angles. Those aren't even where 3 is at. 6 is over here, 7's here, and 4's here. You were talking about angle 3. So, way to fail on like a bunch of different counts. Now, let's keep going. Yeah, I'm making fun of people, and just get over it. Alright, so let's talk about what you were supposed to do. Angle 3 is here. You had to give me that wall, which is R to Q. And then angle 3 is here. That's that wall. That's R to P. And that's all you have to do. Just give me the wall. RP, RQ. We talked about that in practice this day, but I don't know where somebody came up with that. Don't give me number systems. That doesn't work. Alright, next one. What's another name for angle number 2? Angle 2 is right here. Okay, so that's like MRN or BRM. I don't really care how you do it, but you gotta give me the wedge piece. I had somebody tell me, like, give me another name for angle 2. Somebody put angle 9. No. 9 is a different angle. So no. Moving on. Name a linear pair. Okay, now these are where we come into like a bunch of different types. Name a linear pair. A linear pair of two angles are side by side and they make a straight line. I would say like easiest one that I saw somebody give me was angle 5. That's nice, angle 5. And then this angle right here, which is angle TPQ. Like those are side by side and they make a straight line. That was perfect. That's easy to look at. I had somebody even clever, like they put a 10 here and said angle 5 and angle 10. Okay, that makes sense. They're side by side and they make a straight line. I had somebody tell me, I think one of the other clever ones was angle 9 and somebody put like a 13 down here. That's clever, right? You had your own number systems. 9 and 13, they're literally side by side. Okay, if you did the letter systems, fine, and any, TPQ, and 5, whatever. There's a lot of different ones. You didn't just have to pick those. I mean, I could have picked this angle and this angle over here, or I could have picked angle 3 and this big angle over here. There's a lot of different like angles you could pick that had to make straight lines. Name vertical angles now. Name 2 angles that are vertical and acute, small. You could not pick 6 and 8. 6 and 8, I know they're vertical, but they're bigger than 90. They're obtuse angles. You can't pick those. I had somebody tell me angle 5 and angle, I think somebody named this like 11. I like it. I can go with that. Those are vertical. I had somebody tell me 4 and the angle over here, they put some extra letters. Cool, I can go with that. But I will not accept angle 9 and angle 3. Those are at like a weird L shape to each other. Vertical would be angle 9 and the one straight across from it, which is that angle down there. Those are vertical. Okay, you have a lot of different options, but yeah. So there was a couple of things I was looking for. Okay, moving on. Okay, number 9. All right, so here's number 9. The hint I gave you when we were taking the test, I said, don't assume that these are perpendicular to each other. That was a hint I said out loud. They are not perpendicular. They look like it. They don't have to be. They can literally tilt it, right? Because there's no 90-degree marker there, so don't assume that they're all 90s. That's assuming that they're perfect T's. So what I said is just use a linear pair. 2 angles that are side by side that make 180. So like these 2 can add together to make 180. That you can assume that's straight, right? Straight line. Just don't assume that they're at a T intersection. Okay, so I can add them to make 180. You can see that, and I did all my math. I can add the other 2 to make 180 and figure out that, and then when I plug the numbers back in, you'll figure out that they're all different angles. So you can definitely see how that works. Questions at all about that? Okay, it was one of those things like I had some crazy answers. I had somebody try to like set the opposites equal to each other like vertically. There was like 2 angles, there was 2 letters going on, you can't do that. That's like some serious algebra 2 math that you were trying to attempt that we haven't got to yet. We haven't even got to like the algebra you could have used on this picture, because it could be rather crazy if you wanted to get there. Questions? All right, I'm going to walk around and collect. You have 1 week from today if you wish to retake. It doesn't matter what your score is. If you failed, you have to retake. So like you don't have the option. You have to be in here. Failing, I believe, is a 41 or below. You failed. It's like that was 61%. So you have to retake. That means you have to come in before or after school. If you can't make that, you have to try to make that because you don't have an option. So, because if all else fails, I'll just call some parents and they'll drop you off and then you have to come take it. So, they'll be real happy to see us do that.
I did it again.
Or we did this like 7 times, something like that.
Addie,
Oh, maybe she does. She
Yeah.
helped plan with Sierra. I'm not sitting by him.
thank you.
Good.
Okay. The bully alley. And your reception's back.
No, I'm not sitting by him.
No, no, you got it.
I was gonna email you back today. What lunch are you eating?
I need my calculator.
No, are you kidding?
Yeah, probably.
Why are you
We're gonna make bread. You always need 4 pieces. Like that. Okay, do I got everyone? All right, perfect. Okay, hey, here's the last thing we're gonna do today. Okay, let me get rid of this. All right.
It doesn't hurt you, it hurts it.
What did I do to you?
Okay, here's the last thing I want to cover today. All right. Okay, we're going to go through the PowerPoint, not the entire PowerPoint. I just want to go over triangles today. Just to go through those words we introduced Friday, in case you were gone, or you just weren't paying attention, you weren't in the right frame of mind. If you already have them written down, have your notes out. We're going to go through them. We're going to do a little activity today that you're going to get points for. It's super simple. Now, here's what I need to make sure of. At least one person in your group. Now, I know we have a couple people that are sitting by themselves. You can move around and sit next to people, but if you want to be by yourself, you're good. Do that. At least one member in your group needs a protractor. So that means that little angle thing, right? So that's why you probably saw some of these laying on the floor today. At least one of your group members needs one. If you don't have one, you're gonna have to ask for one. At least one person in your whole group needs one. Next, one member of your group will be getting a ruler here in a minute. Okay, an actual measuring device. When we measure today, we're going to use the centimeter side, so the metric system. Okay, because I think it's more accurate than the U.S. customary side, because I have rulers that only go to 16ths. The metric system is a little more accurate for our purposes. Okay, so does everyone understand what we're doing? We'll get to these here in a minute. I'll handle the rulers here in a second. Does everyone have a protractor in your group? Does any group, are they going to need one? Okay, you guys are going to need one. Okay. Anyone else going to need one today? At least one person's got it. All right, we'll get to the example here in a minute. If you just have those out, I'll explain them here in a minute. All right. Okay. So here's our PowerPoint. I want to go through triangles only. But first, what we talked about on Friday, we had a lot of different vocab words. The big topic here was we're talking about polygons. What everyone thinks geometry is, the names of shapes, right? I introduced the first 10 names to you. I'm going to go through those names right now so you can see them. But our goal today is to focus on triangles, because there are 7 types of triangles. So first, the polygons. First type, obviously, I just said it, was a triangle, right? 3-sided figure. We're going to look at all 7 words today, but we're going to do a little activity where you have to put it into practice. Like, how does that even apply to my picture? Okay, we're going to do that here in a minute. And you're going to turn that in for easy points. Second term we talked about on Friday was a quadrilateral. We have not seen all the different types of quads yet. I believe we've introduced the word, and then I just kind of left it at that. We're going to look at them all tomorrow. That's tomorrow's goal. Okay, quads are 4-sided figures. Okay, quad meaning 4 laterals or sides. Okay, now pentagon is 5-sided, Pentagon building, right? 5 walls. Hexagon is 6. Hex literally has an X in it, like the number 6. That's how I remember it. Hexagon is 6. Heptagon or septagon is 7. Octagon is 8, because like octopus is 8. Octopus, octagon. Nonagon is the term I'll use for a 9-sided. Now your book says 9gon, but I like nonagon. That's the term I'll use on a test, intent. Decagon is literally the metric word for 10 and Latin word for 10. Deca is 10. 11gon, or what I use is hendecagon. Hen is 1 more than a decagon. That's Latin for 1 more than 10, so it's 11. And then dodecagon is 12. Now there is other names. We only do the first 10. After 10, after I guess dodecagon, the 12-sided figure. After dodecagon, we just call them 13gon, 14gon, 15gon in this class. I know there's terms. We only call them by their generic terms. Your book refers to 9gon and 11gon. I have these terms. You need to know these terms. Those are the ones I use on the test. Okay, is there any questions with the stuff we introduced on Friday? I think most people know those, correct? All right. Does anyone still need those or need to make corrections? Okay, T, just let me know. Let me know, because I know you were gone the other day. Now, we added more words in this T, so what I would say is, like, for Fridays, go back and watch that video maybe sometime this week, and look at the PowerPoint. I'll have the PowerPoint. There's a couple other slides that we had that have some other terms. But this is, like, the main goal is to talk about names. So, okay. All right, hey, are we good so far? Everyone's good? T, are you good? All right, hey, we're moving on. All right, so now here's our goal today. I only got this one slide, or 2 slides I want to go through. It's just on triangles, that's it. After triangles, we're done today. triangles are three-sided, right? You classify the name by its sides. Well, tri literally means three, right? Tricycle, tri, three. So three sides, or three edges, that's the word we use, or three vertices, three angles, right? The vertices are the corners, right? That's where the angles sit. There's literally three angles, there's three walls, three edges. Okay, now when we name a triangle, other than just looking and say, oh, that's a triangle, there's names we use, right? Every triangle has two names. So when I look at this triangle, I can already think of two names I can call it, right? Because of the way we classify it. Number one, you can classify it by its side measure, right? Side length. That means you literally pick up a ruler, you measure the walls, and then we call it a name, right? Depending on what those numbers are. Then after you're done, you called your triangle that name, you would then take out your protractor, you know, the thing with all the angles, can I borrow that one? No one? You would take out your protractor, and then you measure the angles in the corners. And so the angles would be the next name. Okay, does that make sense?
Sure.
Okay, so what we're gonna do today, we're literally gonna experience this, that you have to figure out what both names are. But now, how we do this is I cut out a bunch of random triangles. And I mean, I'm talking random. Like they are all very, very different types of triangles. And every person in this room will get one. So they're all different. I can guarantee that. And you have to figure out what to call them. Now, I'm not gonna just turn you loose. We're gonna go through the naming system so that we're gonna take like 5 minutes, you're gonna look at your picture and figure out what name to call it, and I'll review it with you. Does that make sense? You are gonna turn this in, so you need to put your name on it right when you get it. Like put it right in the middle of that triangle, just on one side. Got it? Okay, here we go. Get that right. Boom. There we go.
It's an anime story.
One.
What are you gonna do with
I feel sick.
You should have. Alright.
Can't wait for Tourist Day. It's Tourist Day, right? Tomorrow.
Yes.
Go full Russian.
Mine was
Okay. Okay, does everyone have a triangle?
What?
Put your name on it right away. Everyone got one, right?
Yeah.
Put your name in the middle of it. Alright, now, we're going to first classify it by its side lengths. So now, to do that, every group in here needs a ruler. So before I hand out the rulers, you start calling it different names. Okay? When you classify it by its side lengths, we're going to measure with the metric system, centimeters, right? You're going to measure each wall. If the walls are all different numbers, you call it scaling. So that means like this is my picture that I have in front of me. And I measured each wall. This wall might be 30 centimeters. Maybe this one was 29.1 centimeters. And this wall was 25.4 centimeters. I would put those numbers on those walls. I'd literally write it on my triangle. And then I would put in the middle, scaling. Does that make sense? All three walls are different lengths. Okay, now if two walls matched, maybe you measure, and two walls were exactly the same. It's called isosceles. Maybe two walls were 30s or 45s. I have no idea what size triangle you have. I'll give you a ruler here in a minute. Okay, so two walls match, it's isosceles. And if all three match, there might be an example of an isosceles or equilateral triangle in here. Or all three match, it's equilateral. I'm betting on 90-some% in here are scalene. There might be a few isosceles, because I did cut out a few, and I think I only have a few left. So there should be at least a couple in here that are really close. And then I don't know if there's an equilateral. But, okay, I'm gonna hand out a ruler. You're gonna have to share this. So, do it real quick. Measure your triangles. I'll hand out more of these here in a second.
I think I'm sick.
At least one person in your group can measure your triangles. All right, I'll hand out a couple more here in a second. So measure your walls, put your numbers down right on your triangle. Here you go. Okay. Boom.
I can't wait.
All right.
I can't wait to eat cold.
Boom, boom.
13 and a half. Let's go.
Boom.
It's not even that
Okay.
bad. I'm just saying, it's not
You're
bad.
gonna get
All right. So measure your walls. Write down the number right on your triangle and use the centimeters, right? So when you measure each wall, you're going to write down the number right on the wall so I can see it, and then figure out which word it is. If all three walls are different, scalene. If two walls match perfectly, because your numbers show that, then it's isosceles, and if it's equilateral, all three match.
Should we just write this in the middle of the triangle?
Yeah, so yeah, just write it right in the middle. Probably your name's there. So you need to put it right next to your name. So do that right now. I'll give you a couple minutes.
These are real. Am I stupid?
Yes.
Oh my god, actually. They're not real. Oh my god, they're not equal.
Let's get it from a dog.
Herpes.
Dog and turkeys and chihuahuas.
That's what I mean by no. What did this give you?
My dog is
It goes like.
What did he say though?
The softest one is going to be the softest.
very warm.
I didn't do anything. It's got me like that.
My nose, you know, you're sitting here.
I missed. That's why I didn't get it. I missed. I hit the desk. I wanted to do it like that, but I went like that.
I did.
I
mean, yeah, you go.
He wasn't trying to paper.
It was supposed to be a surprise.
Yeah.
Got a hole in paper.
No, I think it's.
Okay, hey, did everyone get enough chance to measure your wall? Now, remember, you need to write down your numbers inside the walls and what name it is inside my triangle. So write it down. All right, now, when you're finished, I'm going to collect my rulers. That way I know kind of when every group's done. Grab these, you're on one.
It looks so good.
Perfect. Two sheets of
I smell it.
All right, so. Okay, next. So now, take your triangle, flip it over. You should be on the blank side. Nothing should be written on the one side. Now maybe you put all your stuff on the one side where you didn't put your name. That's fine. You should be on the blank side, hopefully on your triangle where there's nothing written. All right, so here's the next thing we're gonna do. We're going to classify it by its angles now. This is where in your group, one group member should have a protractor like this. Now, if you don't have a protractor, I'm going to walk around, I'm going to hand some of these out because I know some groups already raised their hand, they needed one. Is there any groups that also need one? Okay, I'll hand out more if we need more, but remember, I want these back, please. Because I'm going to need these. Okay. Alright, so here's what we're going to do. Now I'm going to walk through and I'm going to show you. We're going to classify by its three words. Now, if your triangle is acute, so I'm going back to my original picture. I'm going to take my protractor and I'm going to measure the angles in the corners. Now, you guys have the luxury where like you can turn your picture. I can't. So I'm going to line up my dot right on the vertex, line up 0, count up. 0, 10, 20, 30, 40, 50, 60, about 67, so this is 67 degrees. I'm going to go to the other angle over here. That's 0, 10, 20, 30, about 39 degrees. And then I'll measure this other one up here in the corner. And this angle ends up being 0, 10, 20, 30, 40, 50, 60, 70, about 73-ish. 73 degrees, maybe 74. Okay, so I've classified it. Now, if all three angles are less than 90, then your triangle's acute, and you're going to write the word acute in there. That's where all angles are less than 90 when you measure. If if one angle is exactly 90, now there has to be a couple triangles in here that are 90s. The reason why it's one piece of paper, there's 4 corners. There should be 90s in the corners. So if you have a right triangle where one angle is a right, you need to measure that. You need to show me that it's a right angle because you're measuring it. There should be at least 4, because I used one piece of paper to cut these. So you should be thinking there's at least 4 right angles on the corners. You got to tell me. Now it could be close, but it's got to be exactly 90 to be a right triangle. Now if one of your angles is bigger than 90, it's obtuse. You need to tell me that number. Maybe you went past 90 and it's 92, or maybe it's 107 degrees. I have no idea. Figure it out. There's a couple of obtuse triangles in here. I know there was. I need to know the angles in the corners. Once you've figured out your triangles, you need to write down the word in the middle. Okay? And then we're going to turn these in, and this is your last thing today. You have 30 minutes before I want these. Does anyone need a protractor to help you out? Because I have a few left if anyone needs one. That's a right angle. One right angle, automatically a right. Anyone else need one?
Oh, wait. One right angle and automatically right.
One right is automatically a right triangle. One obtuse is automatically obtuse. You know? Yeah. Anyone else see one? We got it.
So this one's supposed to be right.
That might be just one. It might have been just what's left. It may not be 190. I think we already had a couple of these, so you might not be.
Will this top one go like this then? So bulgy.
Yeah.
I don't know.
Oh, yeah. Line of 0.
This angle?
So, remember, give me your angles in the corners. When you are finished, done, complete, names on it. I want these triangles. If you borrowed a protractor from me, I would like them back. Okay? But you are turning this in. This is easy points. I thought this was kind of fun to get a little hands-on, get some practice doing it. So, because we don't get to do this too often. It's actually showing that you know what words to apply. We're going to do this more throughout the shapes, so you get to see it, you get to physically touch it, see what kind it is. It's the easiest way I could just demonstrate to you what properties you're looking at.